Hi, I'm Andy Heron, Product Manager for MXnet, and welcome to the MXnet USP series training. Throughout this video series, you'll learn the ins and outs of MXnet USP and all the knowledge you need to spec, design, and build a successful MXnet USP system. So without further ado, let's get into the details. So what is USP? USP stands for Universal Streaming Platform, and is a series of transceivers that encode and decode using H.265 or H.264 codecs. Due to USP leveraging H.266 compression, this makes them a very low bandwidth solution, and incredibly easy to scale even to the largest size systems, with hundreds if not thousands of endpoints. USP incorporates what's called AVPro Flow. Flow enables interoperability with third-party AV equipment by using open standards H.265 and H.264. This brings a tremendous amount of flexibility to system designs that wasn't achievable with previous versions of MXnet. We'll talk more about this in a little bit. USP is designed for AV systems that need scalability and AV device interoperability over having ultra-low latency video distribution. So having said that, here are some key application areas where USP will excel. USP has many features that lend them very well for use in hospitality, such as a bar, restaurant, or casino. USP is also great for lecture capture environments, such as a higher ed classroom or auditorium. Mass video distribution systems, like those found in transportation facilities, can take advantage of many of the unique capabilities of USP. Likewise for government facilities, such as courtrooms or command and control systems. And as we'll talk about, USP can also be used in corporate use cases, such as an office building or meeting spaces. So let's break down the three models. USP consists of an ES, a PL, and a PR, which stands for Essential, Plus, and Pro. All of these models are fully interoperable with each other. This means you can mix and match them in a single system design, giving you added flexibility to keep system costs down and not over-specifying on AV processing capabilities. They truly allow you to tailor your design to exactly what you need. As far as I/O, all three models have a lot of similarities to existing MXnet products. If we take just a quick run-through, let's start with the ES. On the front panel, you'll notice that there's status LEDs, an info screen, a reboot button, and I/O for debugging and updating. On the rear panel, we have a DC power option if the network switch doesn't support PoE. For peripheral control, there's RS-232 and IR connections, an HDMI in and HDMI out for encoding or decoding AV content. The HDMI also supports CEC control, along with a balanced audio breakout, and of course, a standard PoE-enabled LAN connection. Jumping over to the Plus model, this introduces USB connectivity and is designed for HID devices such as a keyboard and mouse. With the Pro model, the USB capabilities increase to USB 2.0 speeds, with the USB-C host connection also supporting DisplayPort alt mode and 60-watt power delivery. So now that we know the models and the I/O differences, let's dive a bit deeper. We'll start with features that are shared across all three USP models. I mentioned in the beginning AVPro Flow, and third-party interoperability is a core functionality of USP, so all three of them will have this capability. All three models are also true transceivers, meaning that they can simultaneously encode and decode through the HDMI in and HDMI out. This brings flexibility to system designs, allowing one physical endpoint to connect to both a source and a display at the same time. All models support video wall processing. While technically no limit, we recommend keeping it to an 8x8 or smaller for quality and performance. Latency performance will be the same no matter which model is selected, and this averages to be around 75 milliseconds end-to-end. All models support media playback and a digital signage functionality. This allows you to upload images and video files, create playlists, and schedule the playlists for your applications, removing the need to encode any external digital signage systems through HDMI. Now let's talk about features that separate these three models. The first is encoding capability. The Pro and the Plus model support up to 4K 60 encoding and decoding. The Essential model supports up to 1080p 60 encoding. You'll notice, however, on the Essential that it can support 4K 60 decoding. This is by design and allows you to route a 4K 60 stream from a Pro or Plus model to an Essential without needing to downscale the resolution, and is a major benefit in mixing and matching models. Bandwidth consumption is relative to encoding resolution. So on the Pro and Plus models encoding 4K 60, it will consume around 60 megabits per second. And on the Essential, at 1080p 60, it will consume around 15. Let's jump down and talk about USB. USB routing and extension is a functionality that's built for the Pro and Plus models. The Pro model supports USB 2.0 data rates, and the Plus is designed for HID applications. The Pro model also supports DisplayPort Alt mode through the USB-C connection, along with 60-watt power delivery. This means that the Pro has two video inputs, a USB-C and HDMI. These inputs can be configured as auto-sensing or manually switched through API commands. 60-watt power delivery through USB-C does require an external DC power connection to be made. Multi-view processing is a feature that is included on all three USB models. The difference is in the amount of windows that can be simultaneously viewed. On the Essential, it's up to 4 windows, on the Plus, it's 8, and on the Pro, it's 16. Last but certainly not least is networked audio. The Plus and the Pro models feature 2x2 Dante or AES67 capabilities, allowing them to both transmit or receive audio from external sources, DSPs, or amplifiers. Let's break down some of the audio flow capabilities on the transceivers. All USP models have 2 audio transmit points that allow audio to be sent over the network to USB transceivers to decode. In the case of the Plus and Pro models, audio can also be transmitted to Dante or AES67 receivers. By default, transceivers are set to an auto switch mode. This means that HDMI is the default audio ingest point until a 3.5mm source is connected. This will then override the HDMI audio. When the analog source is disconnected, the transceiver will switch back to HDMI. In the Mentor interface, you can choose the audio source mode between Auto, Force 3.5mm, or Force HDMI based on your requirements. Now let's talk about audio receiving flow. USB transceivers can decode and output audio through the HDMI and analog audio outputs from several different audio sources. This includes the local audio ingest points on the transceivers, or from any USB encoder or Dante transmitter on the network. Only one audio source can be decoded at a time. Now that we have a good understanding of the USB product line, its features and specifications, let's take a few minutes and talk about AVPro Flow. So, what is AVPro Flow all about? I mentioned in the beginning, Flow's purpose is to support interoperability through H.264. The name signifies how AV signals can quote-unquote flow between various manufacturers' products to create hybrid AV systems. USP is the first series of products that will be flow enabled. However, many more products will be added as time goes on. Let's go down another layer and talk about how AVPro Flow and H.264 interoperability works on USP. You're probably asking yourself, well, what third-party devices are compatible with USP? The answer is virtually any device that is capable of encoding or decoding an open standards H.265 or H.264 signal. There are thousands of devices in the market that have the potential for interoperating with USP. The next question you might have is, well, what does open standard actually mean? Open standard means that the AV encoding and decoding of H.264 is using standardized methods that have been defined by ITU and ISO IEC, and the device is not using a proprietary or vendor-specific version of H.264. Typically, a manufacturer will make a point in documentation or supporting materials to call out open streaming as a functionality. If you don't see this terminology, then it may be the case that the product is using a proprietary implementation. When encoding or decoding H.264, there are several different implementations that can be used. These come in the form of what's called profiles and bitrate levels. These control how the content is encoded and is key when considering stream interoperability. For H.265, USP supports main and main 10 profiles, and with H.264, it's baseline, main, and high profiles. For both H.265 and 264, main and high bitrate tiers at level 6 or lower are supported. USP is capable of transmitting this content through a few different network protocols. RTP is used for a private stream between USB endpoints, This stream is encrypted and supports the distribution of HTTP protected content. RTSP is used for open standard streaming between USP and third-party devices, and RTMP is used for streaming content to internet-based services such as YouTube. Let's walk through a couple use cases together to really get a good feel for how you can leverage this interoperability. The first benefit and use case is decoding external H.264 streams. This example illustrates how you can decode IP cameras directly over the network. Without USP and AVPro Flow, you would need to connect an AV encoder to a camera's HDMI output to route it to remote displays connected to AV over IP decoders. USP eliminates the need for the additional encoder and can natively decode an RTSP stream from a camera. This same concept can be expanded to many different types of cameras, such as decoding IMAG document cameras in a higher education environment, or security camera systems in a command and control application. In scenarios where there's several cameras, you can leverage USP's multi-view processing capability to create a composited output of up to 16 cameras at the same time. A second benefit and use case is essentially the opposite, where we can use USP to encode through open standards H.264 to third-party hardware or software decoders. In this example, USP is encoding an HDMI or USB-C laptop through RTSP, and it's being decoded by OBS Studio for the stream to be used in a capture or live production environment. Without USP and AVPro Flow, in order to get the laptop's content into the production PC, the design would require an additional AV over IP decoder to reach the remote PC, and an HDMI to USB capture card to ingest content into the PC. This is a great design for applications such as a courtroom, where content is typically distributed locally but also recorded and stored for record keeping, or in live events where multiple external sources need to be brought into a production software and composited in real time. Similar to the previous use case, USB encoders can also directly stream to internet services such as YouTube, Twitch, Wowza, Restream, and many other platforms through RTMP. This can be great for live events that also want to stream their services to remote viewers, such as House of Worship, or perhaps in a corporate environment where a business is giving a town hall meeting to local teams and also wants to broadcast to remote employees. Since many MXnet systems are isolated and don't have access to internet, we've designed a feature available on the C-Box called Media Bridge. This allows the streams from USB encoders to be bridged from the AV network into a control or IT network with internet. Here's a closer look at a basic media bridge design. The source device is connected to a USB encoder within the AV network, but the user wants to send the laptop's content into a production PC that's in the control or an existing IT network. By enabling Media Bridge on the C-Box, the stream from the USB encoder can be encapsulated and converted into the IT network. This design can be used for streaming to internet services in the same way, by enabling RTMP as the streaming protocol and configuring parameters for the service through Mentor. Media Bridge works both ways. Not only does it allow content from a USB encoder to reach control networks, but it can allow compatible third-party devices in the control network to be decoded by USB endpoints in the AV network. This type of design is commonly found with pre-existing IP security cameras. Through Mentor, you can add in open standard URLs from third-party components, and then enable the Media Bridge conversion for them to be encapsulated into the AV network. Be aware though that there is a limit to the total number of streams, both from the AV and IT network, that the C-Box can bridge due to processing capabilities. Now, let's connect to a live USB system, and I'll walk you through the new software configuration options in Mentor. We'll start on the System Utilities page. On this page, we can choose how we want USB endpoints to operate. By default, encoding and decoding are both enabled. If you want to specifically disable a particular mode, you can click on the Set Device Mode button and uncheck a mode to disable it. This will also affect the Configure page, and will remove the device from either the encoder or decoder view based on what you've chosen. If we move to the Configure page, you'll notice that some settings are unique to USB endpoints. If we click the Edit button in the Stream Settings column, this will bring up a configuration window to enable open standard streaming. By default, USP is not configured for open streaming and will only encode or decode between other USP devices. To enable open streaming, simply enable the toggle switch. It's important to note that open streaming cannot be enabled if HDCP is detected due to copyright reasons. A few parameters can be adjusted in this window, such as choosing H.265 or 264 as the codec, and setting the H.264 profile mode, bitrate, and bitrate modes. Additionally, you can set which streaming protocol you wish to use. Let's configure an open standard stream from this encoder that's connected to my laptop. I want to send the stream into OBS Studio. I'm going to set H.264 as the encoding method and the protocol is RTSP. I'll leave all the other configuration options on their default settings. I'll click Save and then copy the stream URL to be used by OBS. You'll notice under the Open Streaming column that this transceiver now shows as enabled. In the Sources section of OBS, click the plus sign at the bottom and choose Media Source. Create a new source and name it. Uncheck the Local File box, and in the Input field, paste the USP URL that was copied from Mentor. You can leave all the other settings on default. Click the OK button, and the USP stream should be visible in OBS. Simple as that. If we pop back into the Open Stream settings again, there's one more important setting to talk about. You'll notice how there are two URLs that can be copied. The encoder stream URL is the direct stream from a USB endpoint and can only be accessed by a third-party device in the AV network. The stream bridge URL is for accessing the encoder's open stream via control or IT network. This leverages the CBOX Media Bridge functionality we covered earlier. By default, Media Bridge is disabled. If you wish to use this functionality, simply enable the toggle switch and copy the respective URL. Paste that URL into the third-party device's software configuration. You can also quickly enable Media Bridge without opening the stream settings pop-up here. Enable the toggle switch and click the copy button to copy the URL to your clipboard. You can see here the number of enabled Media Bridge streams. Another new option is to add in external H.266 sources to be decoded by USP. This can be done by clicking the Add Edit External Source button located on the Configure page. Within this window, you have the option to insert an RTSP stream URL. But first, make sure to give the device a custom name and a model name. If you're unsure of the RTSP stream URL for the third-party device, consult your device's user manual, as this is typically documented. Once you know the RTSP URL, paste it into the stream URL field. The location drop-down menu is important. This tells the CBOX whether the third-party device is in the AV network or control network. If it's in the AV network, then the CBOX will not use the Media Bridge functionality. If you choose Control Network, then it will automatically consume a Media Bridge conversion stream. Each device that you add from the Control Network will consume a stream. If the RTSP stream from your device requires a username and password to access it, you can enable the authentication toggle and enter that information here. Once done, click the Save Add Device button and close out of the pop-up window. Hit the refresh button and you'll now see the external device listed. You can navigate to the Auto Matrix page to see the live stream and route it to any USP decoder. Okay, now let's talk about the media player section. This section allows you to upload images and video files to endpoints to create digital signage experiences. To start, let's upload some content. I have a couple images and a short video clip that I want to play back. I'll select the files and allow them to upload. With my content now uploaded, I can get to work. I need to create a playlist and add the content I uploaded to that playlist, which is as easy as clicking the plus icon and entering in a name. I'll drag the content into the playlist and place them in the order that I want. Content can be reordered once added by long pressing and dragging it to a new position. For images, you can choose how long you'd like for them to appear before moving on to the next piece of media. If I want to make sure things are working correctly before sending this to all my USB endpoints, I can click the Test Playlist button. Once I'm happy with the playlist, I'll hit Apply. Then I'll select the USB endpoints I want this playlist to live on, and I'll click Send. You can immediately have the playlist start playing on the selected USB endpoints by clicking the Play Now button, and vice versa, stop the playback. This is great for testing purposes, or if you don't need to create a schedule and want the content to continuously play back, and don't intend to route USB encoder streams to the endpoints. For this playlist though, I want to create a schedule, so let's pop over to the Scheduler tab. Let's create a schedule for the work week. So I'll select Monday through Friday, and I want it to start at 9 AM and end at 5 PM. Once set, I'll save the schedule and apply the schedule to the selected playlist. And that wraps up the USP training. We hope that you've enjoyed taking this course, and happy installing!